to solve mixture applications, we're going to start off with a cost equation for something that has a unit price. So the cost of something that has unit price is the unit price multiplied by the number of units. For instance, if peaches are sold at a unit price of 14 cents per ounce, what is the cost for 12 ounces of peaches? Since the units here are ounces and I'm being given the price per ounce, all I have to do to find the total cost is multiply the price per ounce, which is 14 cents, by 12 ounces. So the cost is 0.14 times 12, which is 1.68. So that's $1.68 for my 12 ounces of peaches. Now, what if peaches are sold for the same 14 cents per ounce, but I want to buy X ounces, an unknown quantity of ounces? Now the cost can be given by cost equals 14 cents, 0.14, times X, the unknown number of ounces, which I can just write as 0.14X. All right, we're going to use this concept now to do a problem that has to do with mixtures when we're trying to break even with two unit prices. So a smoothie shop owner wants to make a 16-ounce protein shake with peaches and protein powder. The peaches are sold for 14 cents per ounce, and the protein powder is sold for $1.24 per ounce. Find the number of ounces of peaches and the number of ounces of protein powder that will cause the shop owner to break even if the cost of a 16-ounce shake is $3.89. All right, let's break this down piece by piece and put it into a table. So the first thing is I see that there's 16 ounces. So I have peaches, protein shake, or protein powder and the shake, and I want to make 16 ounces of the protein shake. 16 ounces of the shake, I'll put that in the bottom row here. And the number of units is the number of ounces, 16. Next, I'm going to look at the unit price for peaches. So the unit price for peaches is 14 cents per ounce. So I'm going to put that in the unit price column in the peaches row. And then the protein powder unit price now is $1.24 per ounce. So I put $1.24 in the unit price column of the protein powder row. And then I'm going to look at the number of ounces of each thing. So I don't know the number of ounces of peaches because it asks me specifically to find the number of ounces of peaches. So I'm going to let that be X. I also don't know the number of ounces of protein powder. So I'm going to let that be Y. And those are my number of units. I have X units of peaches. I don't know that amount. I have Y units of protein powder. I don't know that amount. But I want to create 16 ounces of this shake. So the total is going to be 16 ounces. All right. So next, I'm going to look at the cost for each of these things. One cost that they've given me is they've given me the cost of the shake. The cost of the shake is $3.89. So I can put that for the cost column in the shake row. And now I'm going to fill out everything else. Remembering that the cost, the total cost, is equal to the unit price multiplied by the number of units. I can just multiply 0.14 by X and 1.24 by Y to get the two entries that go into this column. So cost equals unit price, which is 14 cents times X, so that's 0.14X, and $1.24 times Y, which is 1.24Y. So here I have the table filled out, and this is all the information gathering I need. I know that to break even, the cost of the peaches plus the cost of the protein powder has to equal the total cost of the shake. And I know that the number of ounces of peaches plus the number of ounces of protein powder is going to give me my 16 ounces for my shake. So I can go ahead and I can actually create a system of equations. This cost plus this cost should equal this total cost. And this number of ounces plus this number of ounces should equal this total number of ounces. So I get these two equations. X plus y equals 16 from this last column. 0.14x plus 1.24y equals 3.89. Okay, so once we have these two equations, we can go ahead and solve them. I'm going to solve this one by elimination. To use elimination, I need to find a multiple of either 1 and 0.14 or 1 and 1.24. The least common multiple of 1 and 0.14, since 1 is the number 1, is just 0.14. So I'm going to focus on getting this top equation to have a coefficient of x to be negative 0.14, so that when I add, the x's will be eliminated. In order to do that, I'll multiply the entire top equation by negative 0.14. So negative 0.14 times x plus y, negative 0.14 times 16. I'm going to distribute this negative 0.14. I'll get negative 0.14x minus 0.14y is equal to, and negative 0.14 times 16 is negative 2.24. Now that I have these coefficients of x being opposites, one being positive 0.14, the other one being negative 0.14, I can add them together. So I'm going to add those two equations together. These are going to cancel out. And when those cancel out, I get negative 0.14y plus 1.24y is 1.1y. And negative 2.24 plus 3.89 is 1.65. To finally solve for y now, I divide both sides by 1.1. And when I divide both sides by 1.1, the left-hand side is just y, and the right-hand side is 1.5. So now I've found the value of y, and y is the number of ounces of protein powder. 1.5 ounces of protein powder. And x now I can find with this equation here, x plus y equals 16. If x plus y is equal to 16 and y is equal to 1.5, then what I'll get is x plus 1.5 equals 16, and I can subtract 1.5 from both sides to get that x is equal to 14.5. So there I've found out how much protein powder to use, 1.5 ounces, and how many ounces of peaches to use, 14.5 ounces. So that's one kind of equation we can use with these mixture problems, mixture of protein powder and peaches, or whatever ingredients you'd want to mix. Let's take a look at another use here. We're going to talk about aqueous solutions now. So when you have a solution, there's a concentration for that solution. So for instance, if you buy alcohol, alcohol has a concentration that's given as an alcohol by volume. And if you double that alcohol by volume, you get what's called the proof of alcohol. So let's take a look at an example. So how much pure alcohol is in 750 milliliter, is in a 750 milliliter bottle of a liquor that is 40% alcohol by volume? So if it's 40% alcohol by volume, let's see. That means that that the proof would be 80 proof. So 40% alcohol by volume would be an 80 proof bottle. To figure out how much pure alcohol is in this 750 milliliters, we'll find the amount of pure alcohol by multiplying the concentration, which is 40%, 0.4, by the amount of solution, which is 750 milliliters. So we get that the amount of pure alcohol is equal to 0.4 times 750, which is exactly 300 milliliters. So 300 milliliters would be pure alcohol in the 750 milliliter bottle. Now let's say we want to know how much pure alcohol is in an X milliliter bottle of a 40% alcohol. Well, in that case, we're still multiplying to find the amount of pure alcohol. We're multiplying 0.4, 40%, by X in this case, the unknown amount in the bottle. And that's going to give us 0.4x, an expression that represents the amount of pure alcohol. All right, let's use that. So a bartender is designing a new drink. He wants to create a 475 milliliter drink that is 20% alcohol by volume. He will use a rum that is 40% and a drink mix that is 5% alcohol by volume. How many milliliters of each of the rum and the drink mix should be used? So we're going to do it the same way. We're going to set up a table. And in the table, we're going to have one row for rum, one row for the drink mix, and one row for the mixture. And the mixture, the combination of the rum and the drink mix, is going to be 475 milliliters. That was given. So this is the drink we're creating on that last row. Now we're going to use a 20% rum. We want this new liquor, this new drink to be 20% concentration. And we're going to use a 40% rum. So we'll put 40% for the concentration of the rum. And a 5% drink mix. So we're going to put 0.05 for the concentration of the drink mix. In order to get this 20% drink, we want to know how many milliliters of each of the rum and the drink mix should be used. So I don't know the amount of the rum, so I'm going to call that X. And I also don't know the amount of the drink mix, so I'm going to call that Y. And I'm going to remember the formula that says the amount of pure alcohol is going to be equal to the concentration of the drink multiplied by the amount of the drink. So if you have a 40% drink and it's X amount, X milliliters of that drink, then the amount of pure alcohol is going to be 0.4x. And if the drink mix is only 5%, but we have Y milliliters, then we're going to have 0.05Y for the amount of pure alcohol in the drink mix. And the final mixture, the final drink that we're creating, 20% of that 475 milliliters is going to be pure alcohol, which is 95 when you multiply 0.2 by 475. So in the pure alcohol column, we just get the product of these two columns because of this formula. Concentration times the amount of solution equals the amount of pure alcohol. And now we can come up with a system of equations, because the amount of pure alcohol that comes from the rum plus the amount of pure alcohol that comes from the drink mix has to be the total amount of pure alcohol in the drink we're trying to create. And the amount of milliliters of the rum plus the amount of milliliters of the drink mix has to add up to 475, because that's what we're trying to create. We want to create 475 milliliters of a drink that's 20%. So we have a system of equations here. X plus Y equals 475 from the last column, and 0.4x plus 0.05y equals 95 from the first column. So we go through and we solve this system of equations. I'm going to get the coefficient of x in the top equation to be negative 0.4, so that when I add it to the other equation, x will be eliminated. So I'm going to multiply that entire top equation by negative 0.4. I'll distribute that negative 0.4 to get negative 0.4x minus 0.4y. And then negative 0.4 times 475 is negative 190. I'm going to add these two equations together, because when I add the two equations, the negative 0.4x and the positive 0.4x will cancel. And negative 0.4y plus 0.5 is going to be negative 0.35. And negative 190 plus 95 is going to be negative 95. So I'll get this when I add these two equations together. And all I have to do now is divide both sides by negative 0.35. When I divide the left by negative 0.35, I get y by itself. When I divide the right by negative 0.35, I'll get approximately 271. That's rounded to the nearest whole number. Once I know that y is approximately 271 to create this drink, I can find x because I know that x plus y has to equal 475. That was the first equation. And I know that y is now approximately 271. So I can subtract 271 from both sides of this, and I'll get an approximation for x. X is equal to 204 milliliters. So to create this drink that's 20% alcohol, 475 milliliters of this drink, I'll have to have 204 milliliters of the rum, which was X, and I'll have to have 271 milliliters of the drink mix, which was Y. All right, so let's use this concept one last time for a finance question. Let's take a look at the formula for interest. Interest is equal to the interest rate times the principal, which is the amount you invest, multiplied by the amount of time that you have invested. So how much interest is earned if $200 is invested at 7% interest compounded annually? The question is how much will be earned after 1 year. So after 1 year, the time is just going to equal 1. So all I'm doing is multiplying interest by principal, the interest rate by the principal, to get the amount of interest that I will earn in 1 year. So that's going to be 0.07, which is the interest rate, 7%, multiplied by $200, which is the principal. And of course, the time we said is 1 year. And that means that the amount of interest then is going to be $14. So in 1 year, I'll earn $14 on my $200. At the end of the year, instead of just $200, I'll have $214 in my account. So what if instead of $200, I invest an unknown amount, X, into an account that pays 7% interest annually? How much will I have at the end of the year? Well, in that case, it's still 0.7 times the amount invested, principal. But in this case, the amount invested is X. So I'll have just 0.07X. So let's use this concept then to solve a problem. So an investor has $73,000 to invest. He must put some of it into an account paying an interest rate of 8% per year, and the rest of it into an account paying 10% per year. If at the end of the year he made $6,560 in interest income from the two accounts, how much did he invest in each account? So we're going to make a table once again. In this table, we'll have the two accounts, the 8% and 10% account respectively, and then we'll have the total, the whole portfolio on the bottom. We know the total of the whole portfolio. The total amount of money invested is $73,000. So I'll put that in the principal or the investment column in the whole portfolio row. Then I see that the one account is paying 8% per year. So I'll let the first account be 0.08 for the interest rate. And I see that the second account is paying 10% per year. So I'll let 0.10 be the interest rate for the second account. Now, I don't need to know the interest rate for the whole portfolio because I've been given an actual interest amount. So that interest amount, $6,560, I'm going to put that in the interest column on the portfolio row. This is a dollar amount, while in this column we have interest rates. So over here we'll have dollar amounts, here we'll have interest rates. All right, so now what we want to do is figure out how much was invested in each account. So we don't know the principal for account 1, that's an unknown, and we don't know the principal for account 2, that's another unknown. I'll label those X and Y, those are my unknowns. And I do know the formula that the interest, the amount of interest in dollars, is equal to the interest rate multiplied by the principal. So to populate these two cells, I can just multiply 0.08 times X and 0.10 times Y, because interest amount is equal to the interest rate times the principal, and like we said, the time is 1 year. So there we have it. Now, this amount, 0.08X, represents the amount of interest earned on account 1. while this amount, 0.1y, represents the amount of interest earned on account 2. So when we add those two amounts together, we should get the total amount of interest from the portfolio, $6,560. And X is the total amount invested in account 1. Y is the total amount invested in account 2. That's the total principal. When you add them together, you should get 73,000. So that gives us two equations. X plus Y equals 73,000, and 0.08X plus 0.1Y equals 6,560. So here are my two equations. I can solve them using elimination. I can get the coefficient of y in the top equation to be negative 0.1, so that when I add it to the bottom equation, the negative 0.1y and the positive 0.1y will cancel. In order to do that, I'd have to multiply the entire top equation by negative 0.1. Now I'll distribute the negative 0.1 to get negative 0.1x minus 0.1y, and that's equal to negative 0.1 times 73,000 is negative 7,300. Now I can add these two equations together. When I add them, the negative 0.1y and the positive 0.1y will cancel, and negative 0.1x plus 0.08x is going to be negative 0.02x, and negative 7,300 plus 6,560 is negative 740. Last thing now, to get x by itself, I just divide both sides by negative 0.02, and the left side will just give me x, while the right side will be 37,000. So x, which is the amount of principal invested in account 1, is 37,000, and I know that x plus y has to be 73,000. So since I know that x is 37,000, that means 37,000 plus y has to be 73,000, and if I subtract 37,000 from both sides, I'll get that y is equal to 36,000. And that's how we use the systems of equations to solve mixture problems.